Hello guys, today in this video we are going to talk about Fright trend problem and Newton's law. We have discussed already what is first law and we will mainly focus on second law and third law. Second law states that if you have any body, you just do all the forces, sum all the forces, and it will produce an acceleration on this object, and this can be identified as the total force on that object is equal to its mass times acceleration. Hence mass in this object is called as some inertial mass. Okay, now what is third law? Third law states that whatever the action you are doing, it has equal and opposite reaction. What does it mean? Suppose here are two guys, guy A and guy B, and they are actually playing some string things. Okay, they are pulling and push and pulling games with the help of string. So what happens, this Alice guy is actually trying to pulling in her side. What happens, due to this the bob will fall to it, but it is not as simple like it. Whatever the force she is applying on the bob is actually feeling that force, and simply it is saying that in the Newton equation that whatever the force you are applying, the same force is acting on that thing as a reaction. You have done some action and there is a reaction in opposite direction, means that you will also be pulled in that direction. So it means that you are feeling some kind of a force. That is the meaning. So when you are applying it, there is an equivalent exact amount of force in opposite direction. It means FA you have applied in this direction, so FB will actually pulling you in this direction. So they are equal and opposite. Now these are the laws which is actually stated by Newton's. Now we have to understand that how can we apply this scenario more or less in any problem, because these are the problems which gonna give you complete understanding of any system, that how can you find the equation of motion on this on any kind of system. Now here is a very good problem. There is a train having three courses like and having some the same mass m. Okay, now they have attached with some engine, and engine is actually giving some force or pulling each and every freight with an equal force like F. Okay, so it is attached with here. So we are naming it, this is your engine, this is your coach 3, this guy is coach 2, and this is your coach 1. Okay, now we have to identify what are the forces is acting on coach 3, coach 2 and coach 1. How will you do it? Now you can see in the figure that these guys are actually attached, therefore whenever any kind of force is acting, they are constrained to move with same kind of acceleration, because they are attached, so they cannot move in other acceleration. They all will share the same acceleration, but obviously the forces acting on it will be different. That is the thing, the acceleration will be same. So whenever same is acceleration, not force. Whenever you are in the train, you see that the whole coach will move with the same acceleration, the way the engine is moving. So everything is having same acceleration but not the force. Then how can we compute the forces on this thing? Now first of all, we have to apply this Newton's third law, that what are the forces actually acting, and we have to resolve it in such a way that okay, some force is acting on something, then it has some reaction onto it. Now for an example, let's say start with the coach 1. Here we have the coach 1. Coach 1 is pulled by some force F, but due to coach 2, when it has some force which is actually trying to pull it, so I am saying it having force F2. Similarly, with what happens to coach 2? Coach 2 is actually pulled by coach 1, and it is actually again pulled by coach 3. Now what happens to F3? Now F3, or we say that not the coach 3, is actually pulled by coach 2 with having some force F3. That is the same force, that is F3. Okay, now everything has mass m, so we will start first of all, because you see here we have only one directional force, and F3, now the whole cart is moving in this direction with acceleration a. So the force, the complete force which is there, this one is F is equal to m. Now it is 3m because there are 3 blocks, 3 coaches with, they are moving with acceleration a. So what is the acceleration through which this complete train is moving? A is equal to F over 3m. It is our first equation. Great. Now we will try to understand what happened with force 3. So we will start with this thing. So F3 will only acting on this thing, and this will be equal to m times a. We know this is the second law of Newton's law, that we have to identify what are the forces acting on any body, and this will be equal to mass times acceleration. So m3, how can we calculate? We know what is the acceleration. Acceleration is f over 3 times m, and this is nothing but F3. Therefore F3 is whatever the force is actually pulling or acting due to engine by 3. So there are 3 trains, so it is divided by 3. Now let's see. So it was second law. Let's see what happens to cos 2. Now we have seen that there is a force. Okay, now here we see there is a force acting because of coach 1. So coach 1 is pulling this side, and coach because of cos 3 there is a acting on force 3-1, because now the everything is moving in this side. So we can do here F1 minus F3 is equal to m into a, and this is m is the mass of second coach. Now F1, what is the F1? Basically it is actually giving you what? It is actually F1 is how much? So F1 is nothing but F2. Okay, so it is nothing but your F2. F2 minus F3 is m into a, and therefore F2 is equal to F is equal to F by 3 is m into a, and a we already know is F by 3m. M cancel out. So this F2 is equal to F by 3 plus F by 3, which is going to give you 2F over 3. Now you may ask why F2? Now we have already seen that this is your F2, okay, and somehow I mistakenly written that because this is the F2, and therefore this for the cos 2 this F2 will acting there, okay, because this is actually attached by this rod, and if it is pulling sometimes this F2, then therefore action and equal reaction, F2 both are the same thing. So it is, so you have to follow the Newton's third law in such a manner. So we saw that F2 is equal to 2F by 3. Now similar idea goes to equation number, so coach 1. Now here coach 1, F is applying here, and similarly F2 is pulling in this side. So what is the force acting on it? Therefore the force F minus F2, which is actually acting on this force. What are the force on cos 2? So F, because engine is applying force F, but the cart 2, or we can say the cos 2 is applying force F2. Now we have already figured out this is 2F by 3. Therefore the force, the resultant force, you can say that m into a, but I am writing at, let's say it is F1, so it is nothing but F over 3. So F1, how much force is actually applying? So you can never write that, okay, because it is attached with engine, so it is actually having some force F. So the force experienced by this cart 1 is only F. No, because it is again pulled by these other coaches also. So this other coaches is actually giving or acting some force, or it is pulling it. So it is experiencing two kind of force. One force is there, one force is there. Therefore resultant force is F by 3. Now here again this F by 3 is acting there, and here it is also acting this side. So it is 2F by 3, and there is only one force is acting pulling this side, therefore it is F by 3. So in some sense everything is distributed. So this is F by 3, this is F by 3, and this is F by 3. Okay, now if you will say that, okay, this is 2F by 3 is acting on this force, F by 3 is acting on this force, and F by 3 is acting in this force. So yeah,